This is the spring lab. You're going to obtain a spring scale, an actual spring, and a hanger. Hang the hanger on the spring. You'll notice the indicator. You can use the bottom or any indicator. You need to line that up with the 0 mark. Once it's at the 0 mark, you're going to start adding weights until it starts to move. As you add weights, you'll notice the first couple weights you add may not change the length of the spring at all. So add weights until it begins to move. And then that is your first data point. Count how many weights are added, 300 grams in this case, and count how far the spring has displaced from its original position. Mark this position, mark the mass, that's your first data point. From there, you're going to add 10 more data points, adding masses, or taking the weight and adding 50s, finding out what the actual weight is, and finding out what the displacement of the spring is. Wait until the spring is in equilibrium, make sure it's not bouncing. Once you have 10 data points, you're going to plot them like so. When the spring hanging downward, the gravitational force in the spring is going to be equal to the spring force pulling upwards. You plot all 10 data points as x, displacement on the x-axis, spring force on the y-axis, you should be able to get a straight line. That line, y equals mx plus b, we know we're going for the spring force is equal to k times x. The slope is going to be the spring constant. The y-intercept is called preload. It's how much force you need to start the spring stretching to begin with. You're going to find both the spring constant and the preload for the springs that you're doing. Supplementary questions are going to be, which of your strings is stronger, which of your springs is stronger, and what was the maximum amount of energy stored in your spring at any time?